You are welcome back to Engineer AGM Plus Academy. Today, we shall explore another interesting topic, and that is charge to mass ratio and atomic mass numbers. We shall discuss how to calculate the charge to mass ratio, their importance, and thereafter, we will calculate the atomic number and mass numbers. At the end of the lesson, you should be able to calculate the charge to mass ratio, and you have to know the application of charge to mass ratio. What does it entail? What does it mean? And finally, you should be able to calculate the atomic mass number of any atom or ions. There are three cases involved when calculating the atomic mass number of atoms or ions. All these cases shall be looked into. If you haven't watched Class 1, Lecture 1 and Lecture 2, to make this lecture understandable and interesting, I will advise you to go back to that module. Charge to mass ratio. Charge to mass ratio is simply the charge carried by a particle with respect to its mass. Mathematically, it is represented as Q over m. It is measured in coulomb per kilogram. What do we understand by charge to mass ratio? How does it apply to real life situation? First of all, we have to understand the fact that proton and neutron have the same mass, while electron is tiny. And again, we have to understand the fact that proton and electron both have the same charge. However, they go in different directions, which has been explained in the previous video. Now here is proton. Here is Mr. Proton, the giant rock. Let's find out its charge to mass. This is its profile, that is the charge is positive, that is 1.60 times 10 raised to the power minus 19, and its mass is given as 1.67 times 10 raised to the power minus 27 kilogram. How do we calculate the charge to mass ratio? Then it means Q over m. The ratio there can be substituted with a division sign. Q is 1.60 multiplied by 10 raised to the power minus 19 coulomb divided by 1.67 times 10 raised to the power minus 27 kilogram. Pick up your calculator and try this. What do you get? I believe you should get the same answer like this. That is 9.58 multiplied by 10 raised to the power 7 coulomb per kilogram. Approximately 95,800,000 coulomb per kilogram. Remember this value. Remember this. As for the small but mighty electron, let's view its profile. And here it is. Electron has a charge of 1.60 times 10 raised to the power minus 19 and a mass of 9.11 times 10 raised to the power minus 31 kilogram. How do we calculate its charge to mass? Its charge to mass ratio is given as Q over m. Then we substitute for the values of Q and m into this formula. That is 1.60 times 10 raised to the power minus 19 coulomb divided by 9.11 times 10 raised to the power minus 31 kilogram. Pick up your calculator and try this. I believe that should give you what? It should give you 1.76 times 10 raised to the power 11 coulomb per kilogram. And what does that mean? It means something close to 176 billion coulomb per kilogram. Now compare this value to that of protons. For proton, we have 95, close to 95 million, and proton has close to 176 billion. Still, do not forget this. It's not compulsory for you to cram or to memorize these values, no. In as much as you know the charge and you do know the mass, then you divide both and you get the value of the charge to mass ratio of these particles. Now what of Madam Neutron? Here she is. As for Madam Neutron, let's check our profile. We have a charge is 0. That is no electric charge, no charge at all. And a mass is 1.67 times 10 raised to power minus 27 kilogram. How do we calculate the charge to mass ratio? Almost the same thing. Charge to mass ratio is equal to Q over M, which is, then you substitute for the values and you have 0 coulomb per 1.60 times 10 raised to power minus 27 kilogram. And what does that give? 0. What does this really imply? Response of charged particles to what? To electrical and magnetic forces. In reality, the charge to mass ratios shows how fast an atomic subparticle reacts to electric and magnetic forces. For example, electron, proton, and neutron, comparing their charge to mass ratio, what does that mean? It means that electron has the highest charge to mass ratio, which suggests that it is the fastest to electric and magnetic force. Whereas proton, compared to electron, is slow, especially in electric and magnetic force. And neutron, no movement. And from that video, you can see when they were on the track, electron moves in the opposite direction, while proton goes to the other side. Fortunately for electron ran as fast as possible to reach the finish line before proton. So therefore, electron moves very fast compared to proton and neutron. In order for us to prove this, we use this equation, that is F is equal to QE, and that leads to mass times acceleration is equal to QE. Where do we get mass times acceleration? Remember that force is equal to mass times acceleration. Therefore, you substitute to get this. And when you divide both sides by m, you have A is equal to Q over m E. This Q over m determines the acceleration of the subparticle, and that is what this equation means. That is to say, if you substitute the value, the charge to mass ratio of electron into this equation, compare it to that of proton, neutron has 0. Therefore, electron is the fastest, or electron is faster than proton in electric field. The same application is adopted when calculating the acceleration of these particles in a magnetic force. We apply F is equal to QVB. In the future, inshallah, I am going to explain how we do this. Application of charge to mass. Does this really make sense? Has charge to mass ratio been adopted by scientists to develop any particular thing? Yes, of course. In our photocopier, in Nigeria we say photocopy machine. In our photocopier, charge to mass ratio is very useful, important. Here we have the document, that is the real document. We have a slant mirror as located in this image here. We also have a convex mirror placed in between two mirrors, just like this. And we have the drum.